you what I'm about to say. Sunshine, she's here, you can take a break. I'm a hot air balloon that could go to space. With the air, like I don't care, baby, by the way. Because I'm clap along if you feel like a room without a roof. Because I'm clap along if you feel like happiness is the truth. Because I'm clap along if you know.
For instance, things getting in production and we change things on the fly and it's getting there and eventually it's getting implemented. And you do quality control. Those slides in the beginning of today was something that I considered to be a miracle. You're building more and more complex systems and you're getting less and less faults on it. You mentioned on the first slide that I have applied mathematics degree. I remember a great lecturer telling me the basic rule of system theory. The more complex systems become, the more faults it will carry. This is law of mathematics. You cannot get out of it. How you do it, I don't know. I hope that by doing the same thing in security, you manage to solve the next great crisis that we're going to face. Come on. What was it? Every 11 seconds, new code getting deployed by Amazon? You're amazing, guys. What you do, I cannot believe that I never believed it's possible. Security, that's us. Security gets things slow. From the basic technology, I want to encrypt this traffic, it means that it will go through slow. In reality, a little bit slower if the cryptography is done right, but still slower. And those security people will come at the most inappropriate moment, somewhere 2 weeks before big release, and tell, hey, did you do this? Oh, you didn't? No, you're not going live. How many of you face this sort of thing? Please raise your hands. Yeah? That's the issue. And security requirements changing. The first time they came and told you, you know what, you cannot go live because of that, you fixed it, and then they came back and said, what about that? No, you still cannot go live. And testing for security requirements is one big unknown. Because the only real testing in most of the places for security requirements is someone like Ari or myself walking into the room and start asking questions. In information industry facing, if we look on the newspapers, we'll find things that 10 years ago was subject of far-fetched science fiction. Neural interfaces. Now, I can use my brain to talk to my computer. And computer will talk back to my brain. I'm wearing my security hat. I'm activating my professional paranoia. And I think, okay, the computer going to talk back to me. And would it go in? So what will happen if someone will hack this interface? And I will become a zombie. Someone will control me, because if you can control computer, then you can potentially control any computer, including that one that's talking directly to my brain. And they were talking that the elevator sitting on the internet. Would you like your elevator to talk to the internet? Yes, again, this is the same thing. It's a computer out there. It's called elevator. And someone can hack in, push some code through it, and stop it in between levels and not allow anyone to do anything. We read one of the recent data stolen from CIA about ways how to remotely control cars. Again, this is a we're talking about kinetic application, potentially with deadly force, in relation to things that we use every day. This is a world we're going to live in just a few years. We have to secure it, or we are risking to live in a very dangerous, strange place. Because another part of that conversation is that for someone to build a cruise missile 50 years ago, that someone has to have incredible resources. For someone to hack a car and make it go crash, they need access to one exploit that potentially could be deployed and sold on the open market and then just published. And everyone can use it. Entry level into having a kinetic weapon driving around the street is a few $100s. Or if you are a few weeks or months searching for it. That's a scary world. We have to do something about it. And it keeps going. Systems are getting more complex, so more potentiality for faults. Attackers get better at what they do. Old saying from NSA, from cryptography specialists in NSA, was that attackers always get better. They never get worse. Because they learn new stuff and they can use old and new stuff. We've never seen zero response. And the only places I believe zero response could happen is in the places who adopt slightly different approach to information security, more from good days of Comrade Stalin. You do mistakes, you get shot. Then people probably not click on anything. We live in the world where people will click. Those guys will get in. And then what they could find and what they do will depend what we do to make that thing secure. And I believe you are the only people who can actually get things better. Because you demonstrated you managed to do it with other software problems, with other infrastructure problems. You managed to build much more reliable and much more complex systems that were possible a few years ago. I hope I got your attention. What to do with it? Simple. The same thing you do with everything else. The same thing. You have specialists across different domains talking to you in one team. Get security in it. If you know the security guys, if they're there, ask them to come, introduce them, and establish line of communication. If they're good security people, they would love it. And don't be afraid to ask questions. Again, good security people love to answer questions. We love to talk about things we know because most of us are passionate about what we do. We want to get things better. And ask for training. There are multiple places, depending what you do. It's the only way how security specialists can operate. And then when you look on this classical cycle of risk, you have asset, there are threats to asset, threats turn into attacks, attacks exploit vulnerabilities, vulnerabilities realize the risk, to address the risk, implementing controls, controls applied to assets, and we go around. When you look at this, in your language, attack is a test. And vulnerability is a piece of code of infrastructure you apply the test to. Every time security comes to you and tell you have a vulnerability, look at it as there were a failed test over there. So what it means, if someone comes with your requirements, you ask for test cases. If I come to you and tell you want, you guys need to validate input from any untrusted source, you need to ask me what is the test case for it. And I'll try to explain, and I'll probably not be able to do it across the board, but gradually we get there. And next time you implement this test case, and you automate it, and one of ever top 10 vulnerabilities of a WASP, from a WASP list will be thing of the past, at least for you. Security tools. I have to say, I've not been doing development for 10 years. The tools I put here is the tools that our great security testers who work with us in Cybersecurity Hub put forward for me. You can script most of that. You can use these tools to actually push stuff in your web interfaces or web APIs and see how they will react. And you should be able to distinguish what is okay, what is expected, what is not expected, which means vulnerability. Before we get to this point, what I mentioned is what I'm trying to say. If you remember earlier today, there was a slide with reinforced and amplified feedback, where in the test you find something and you push it back and it's getting development, it's fixed, and next time that problem does not appear because now it is part of your automated testing. That amplify feedback. Get security into that feedback. If it will get in that feedback, those elevators are not going to be hacked. Or it would become so expensive to hack them that probably people wouldn't want to, unless those elevators running in a particular strange place where someone could actually put a lot of money to hack it, which make all of us and all our lives a little bit safer in the future. Talking about penetration testing, this is one of the favorite topics that I love to talk about it because our organization do a lot of it. We're wholesaling security testing here in Australia. When you as a developers or integration engineer get pen testers, that's what you see. You see that something that is part process, part art. And quite often a dark art because no one actually knows what is happening there. For that to be efficient, to make sense, it has to run on something that's very closely looking like production. There's no point to run it in a something which is far away from production because it will find so many problems that are totally irrelevant to the real world because in the real world, maybe those controls are tightened. It requires specialized expertise. Some of that stuff can be done by non-specialists, but at the end, it has to be someone who understands, who has a mindset of a hacker. Definitions that I remember from old days, and I do remember, I actually coded on OS 370 years ago in university. That was a thing called Hacker's Test. Great program with a text in it asking you a lot of strange questions.